Hello and welcome to the MAML Manual. I'm Iris.
And I'm Sebastian.
And today we will be covering 9 problems from meet number 4, topic number 1, arithmetic with literal equations. Let's jump right into it. Alright, here's our first problem. So I'm not really going to cover anything before we jump right into the problems, because arithmetic with literal equations in simpler terms is just kind of rearranging variables to solve for a specific one. So a lot of this knowledge that you'll use to solve these problems will just come from basic algebra and algebra 2 skills. Okay, so let's get started. If ax is equal to a squared times b times x plus a times b times p over ax plus p, where a is greater than 0 and a times x does not equal negative p, find x in simplest form. Okay, well, we already have ax over here. Let's divide both sides by a so we get x isolated. And yes, that doesn't get rid of all of our x's, but you'll see where I'm going from here. So we divide both sides by a. We get x is equal to a squared bx plus a bp all over a squared x plus a p. Now, you might notice we are able to cancel out an a from every single one of these terms. Let's start by doing that. So now we have x is equal to bx plus bp all over, abx plus bp is equal to ax plus p. Now, okay, let's look for some similarities here. We have ax and a b, and a b and a p. Well, down here we have ax plus p. Let's factor out the b from the top. So we have x is equal to b times ax plus p. And quick note, in case anyone is wondering why I took the b out, is because b is multiplied to every single term up top here. So it gets us the same thing as if I were to distribute this b to each of these terms. So I'm factoring out the b all over ax plus p. Look at that. We can cancel our ax plus p factor down here and our ax plus p factor up here. Cancel them out and we get x is equal to b. That is fully simplified, and that is our final answer. Alright, here's a slightly simpler problem than the last one. And also, you might notice, this is actually the surface area of a rectangular prism. We have our S is equal to 2LW, and they actually even did variables that match the values you're solving for. S is surface area, length, width, length, height. Anyways, little quick thing, these problem writers aren't as creative as they think, I guess. Alright, solve the following for h. Okay, so what I'm going to do is use something that we used in the previous problem. I'm going to try and factor out the h. Well, I can't do that with all of these terms because they're not all h terms. So I'm going to subtract the 2LW over to this side. So we get s minus 2LW is equal to 2LH plus 2WH. Now, I can factor out an h from every term on this side. So I get s is equal to s minus 2LW is equal to h times 2L plus 2W. Again, I found a common factor between all of these terms, and I pulled it out. So if I were to distribute it again, they would be equal. So now, I'm solving for h. Well, let's divide both sides by 2L plus 2W, so I can isolate h. So we get s minus 2LW over 2L plus 2W is equal to h. Can't do any more simplifying, so that is your final answer. And if they're asking to solve the following for h, in your answer you can include the h equals or you don't have to include it, and that also counts as your final answer as long as it's fully simplified. If it's not fully simplified, your answer is incorrect. All right, let's move on. Okay, solve for A, assuming B is not equal to -1/2. 2x is equal to 2a plus 4ab minus 2. Okay, well, I need to solve for A. I have two terms here that are A terms, meaning that they include A in the multiplication of those terms. So I'm going to do the same thing we did last time. I am going to separate any of the non-A terms from the A terms. So I'm going to add a 2 to both sides. We get 2x plus 2 is equal to 2a plus 4ab. Now before I factor out the a, I'm going to cancel out a 2 from each of these terms so I don't forget to do it at the end because, like I said, if your answer is not fully simplified, it will count as incorrect. So x plus 1 is equal to a plus 2ab. Now I'm going to factor out the a from these two terms. So you have x plus 1 is equal to a times 1. And remember, when you divide an a by an a, doesn't leave you with 0. It leaves you with 1. So don't make the mistake of just putting 2b in the parentheses here. 1 plus 2b. Divide both sides by 1 plus 2b, and you get a is equal to x plus 1 over 1 plus 2b. And that is your final answer. Now, again, pretty simple. Just one thing to notice, factoring. Factoring is your friend here. You're going to want to gather all of the terms that include the variable that you're looking for and factor out that variable so you can divide by the rest. All right, let's get onto a little bit harder problems. All right, here's our first 4-pointer of the video. Given that d is equal to rt and r is equal to 2x squared minus 1, find x if d is equal to 7 and t is equal to 18. Express your answer as a fraction. All right, so they're actually giving us values to plug in this time. If they didn't give us values, well, we'd use both equations and use substitution to simplify as much as possible. But they're giving us values for some of our variables. So we know that d is equal to 7. So using this equation here, we're going to say 7 is equal to r times t, which they've given us as 18. So our goal is to solve for x. So I'm going to solve for r here, so we can plug a number into this expression and solve for x. So divide both sides by 18, and you get r is equal to 7 over 18. Now, let's plug it into this equation here. 7 over 18 is equal to r, and r is equal to 2x squared minus 1. Okay, now let's simplify. Add a 1 to both sides, so 18 over 18. So we get 25 over 18 is equal to 2x squared. Let's divide both sides by 2, and we get 25 over 36 is equal to x squared. Now, let's take the square root of both sides. Conveniently, we have two square numbers here. But before I answer, it's very tempting to say, oh, okay, x is equal to 5, 6. But no, x is equal to plus or minus 5, 6. So we have to make sure we include negative 5, 6 as well. And those are your final answers. All right, next up we have a pretty fun one. Solve the following for C. Well, for a lot of you, this may look very, very familiar. And if we were to try and solve it from here, it would be very, very, very difficult to actually solve for C. But I know hopefully a lot of people watching this recognize this as the quadratic formula, which is taken from the variables in a quadratic in standard form. And so a quadratic in standard form is 0 is equal to ax squared plus bx plus c. Same exact variables we're pulling from the quadratic formula. So, instead of solving for c up there, let's isolate c down here. This one's actually pretty simple. We subtract c from both sides, and we can't answer in terms of negative c, so we multiply everything by -1. You get c is equal to negative ax squared minus bx. There we have it. A very, very, very simple way of solving a potentially very complicated problem. These patterns are really important to recognize so that we don't get stuck trying to solve for c from an expression like that. All right, let's move on. All right, here's our first 5-pointer of the video. And yes, you may have noticed I only did 2 4-pointers, but I think you guys can handle it. So, the surface area of a cylinder is A equals 2 pi r squared plus 2 pi r times the height. Solve the equation for the radius. Express your answer as a single fraction in simplest form. Okay, well, something that jumps out at me right away is this looks like a quadratic. This is really important, recognizing patterns, like the problem that we previously did with the quadratic formula. If you notice, okay, it looks like r squared is basically our x term, which is very convenient. If we were to plug this into the quadratic formula, we would be solving for r. So I'm going to rewrite this in our standard form for a quadratic. So I'm going to subtract a from both sides. 2 pi r squared plus 2 pi, I'm going to write the h over here because that's part of our coefficient, r, minus a. Now, let's use the quadratic formula. We have negative b, which is negative 2 pi h plus or minus the square root of b squared, which will end up being 4 pi squared h squared. And no, you cannot leave the exponent out. You have to distribute the exponent for it to be fully simplified. Minus 4ac. So minus 4 times a, and don't get caught off guard here, this is technically c, minus 4 times a, so 4 times 2 pi is 8 pi, times c, which is negative a, so we have minus negative 8 pi a, so we have plus 8 pi a, all over 2a, and a is up here, so we have 4 pi. And that is equal to r, our radius. And notice, we're solving for the radius in this situation. Can the radius of something ever be negative? No. So that's the key here. So instead of plus or minus, since we're starting out with a negative number, we can't subtract another number from it. That will never get positive. So it's just going to be plus. And if you included the plus or minus, yes, that would unfortunately be wrong. Okay, now that we've got that little trick out of the way, where it's just plus, since we're solving for a positive value, let's simplify. So what can we do from it? Well, we can pull out a 4 from each of the terms on the inside. So we have 2 pi h plus 2 times the square root of pi squared times h squared plus 2 pi a, all over 4 pi is equal to r. Okay, now let's cancel out a 2 from the top and the bottom. So we have negative pi h. I accidentally wrote plus or minus here. That could definitely catch you. Plus the square root of pi squared h squared plus 2 pi a, all over 2 pi. And that's equal to our radius, and that, fully simplified, is our final answer. All right, here's the next problem. If this equation, where m is not equal to 1 or negative 1, solve for m. Express your answer as a single fraction in simplest form. Okay, so first, you can see over here, we have two fractions added together is equal to another fraction. What I want to do immediately is find a common denominator between these two and combine them. So, conveniently for us, if we multiply this one by m plus 1 over m plus 1, and this one by m minus 1 over m minus 1, the denominator is pretty simple. It's a difference of two squares. So we get our denominator is equal to m squared minus 1. And our numerator is going to be a plus 2 times m plus 1 plus b minus 2 times m minus 1. So now we have to FOIL the top. So on the top we have am plus 2m plus a plus 2. And over here we have plus mb minus 2m minus b plus 2. All over m squared minus 1. Okay, let's combine things. Well, we have our 2m cancel. We can add these 2's together, but other than that, I think that's all the combining we can do. So we have am plus a plus mb minus b plus 4 all over m squared minus 1. And remember, that is still equal to this fraction over here. A minus 2b plus 8 all over m squared minus 1. Now, initially, I would say, let's cross multiply and solve. Well, in this case, our denominators are the same. And for these two fractions to be equal to each other, the numerators also must have to be equal. So I can just ignore the denominators and set our numerators equal to each other. So we have am plus a plus mb minus b plus 4 is equal to a minus 2b plus 8. Okay, and we're solving for m. So let's get all of our m terms on one side and all of our non-m terms to the other side. So we have am plus bm. Now on the other side, we subtract the a, so our a's cancel. We add a b over here, so we have negative b. Subtract a 4, so we have plus 4. And now, let's factor out the m. m times a plus b equal to negative b plus 4. If we divide both sides by a plus b, then we have solved for m. So we have m is equal to negative b plus 4 all over a plus b, and that is our final answer. Honestly, not too hard of a process. Alright, let's move on. Alright, moving on. This problem is actually pretty interesting. It actually incorporates some knowledge that you should have from another topic that is on this meet, so convenient. Alright, solve a is equal to 1 over a minus e times p to the d power. Alright, so since we're solving for d, let's just work backwards. Let's subtract the 1 over a from both sides. So, side we have a minus 1 over a is equal to negative e times p to the d power. Okay, let's combine these over here. Let's get a common denominator. Right, we have, let's multiply a by a over a, so we have the denominator a. So we have a squared over a minus 1 over a, so that gives us a squared minus 1 over a. That's equal to negative e times p to the d power. Right, let's divide both sides by negative e. A squared minus 1 over negative e a is equal to p to the d. Now, here's where our knowledge of another section of this meet comes in. I'm going to rewrite this using logs, so we can solve for d. So we know that log base p is equal, or log base p of a squared minus 1 over negative ea is equal to d. And there's no more simplifying you can do from here. You don't want to use any log rules to split this up. This is your fully simplified answer, having solved for d. There you have it. All right, here's our last problem. Before we get started, just a quick reminder. This is the arithmetic with section, or just the arithmetic section. So yes, most of these problems will be about arithmetic with literal equations, but there is a solid chance that they will throw in just a general arithmetic problem. So be on the lookout for that. You know, make sure you're practicing those skills as well. All right, let's get into it. If 9ax plus 9by plus 105x is equal to 4ay plus 66y plus 13bx, find the value of a minus b if neither x nor y are 0. All right, this one is a pretty long process, and it's easy to get tripped up in the simple algebra of things along the way. So, we are going to be solving for a numerical value here, which makes it a little bit more complicated. So I'm going to rewrite this, bringing every single term to one side, just so we can kind of evaluate and see if we find any patterns from there. And I'm thinking, since there are 3 x terms and 3 y terms, I'm going to group those together. So let's start with our x terms. We have 9ax, and we have the bx over here, so minus 13, bx plus 105x. Now for our y terms, plus 9by minus 4ay minus 66y is equal to 0. So, looking at that, we can say, okay, there's an ax term and a bx term and just an x term. Same with over here, ay term, by term, just y term. So what I'm going to do is bring the 105 and the 66 x and y back to this side with the 0. So I'm going to rewrite this 9ax minus 13 bx minus 4ay plus 9by equal to 66y minus 105x. Now, if you look at this, we can say, okay, so we have x terms and an x term over here. Well, if x isn't 0, then we know that these terms could not contribute to this x term over here. So only these x terms are going to add together to get our x term over here. Same goes for the y term. So we can say 9ax minus 13bx is equal to negative 105x. Because we know that the only way we're getting the 105x over here is from these two terms. So we have this, not 19, and also we can say negative 4ay plus 9by is equal to 66y. Okay, now we have a system of equations. Let's cancel out the x and y from each one of these terms. Since everything's multiplied by x, divide everything by x. Same for these y terms. So I'm going to rewrite that. 9a minus 13b is equal to negative 105. And we have negative 4a plus 9b is equal to 66y. Now, I'm going to multiply this whole equation by 4 and this one by 9, so we can use elimination to solve for our variables. So we have 4 times 9a is 36a, 4 times negative 13b, negative 52b, And then we have 4 times negative 105 is going to be negative 420. And now this equation, we have 9 times negative 4a, so negative 36a, plus 81b is equal to 594, is equal to 594. Okay, now if we add these together, we cancel out the 36a, add these two together, and we get 29b. Add these together and we get 174. All right, let's divide both sides by 29 and we get that b is equal to 6. Okay, let's choose an equation, plug b in, or just plug 6 in for b, and solve for a. We have negative 4a plus 9 times b, or 6, is equal to 66. So negative 4a plus 54 is equal to 66. Subtract 54 from both sides, we get negative 4a is equal to 12. Divide both sides by negative 4, a is equal to negative 3. Now, let's solve for a minus b. Well, a is negative 3 minus b, which is 6, is equal to negative 9. And that is our final answer. These were 9 problems on meet number 4, topic number 1, arithmetic with literal equations.
Thanks for watching.
I'm Iris.
And I'm Sebastian.
And we are the MAML Manual.